So we talk about data, we talk about statistic. Now we want to apply what we have learned about statistic on the real data. So this is the real data from my previous, just recently conducted midterm for my material class. So this is the real data. So I disclose I don't put the student name and so on, but basically this is the real data lah from that. So you can see I have 63 students in a class, 63 students. So if you want to sort of like replicate this data, I can show you here. Okay, so you just snap this picture later on, and then you replicate the data. It's just the data. So what is this data is all about? This is basically the number, the score, the exam score for the student, for the 63 student. Okay, so this is all the score. So when you have this score, this is data. So as I said before, most of the data, if you do it correctly enough, then you will get sort of like apa orang kata, this linear distribution, normal distribution. Okay, so let's see, is that hold up? Okay, so this I order the data from 1 to 63. It's the same data as before, as you see in the cluster. It's just I put the numbers lah. So I have 63 students, I have this data. From the onset, it's very difficult to see. It's quite scattered lah. It's quite scattered. So you can see on Excel, you can sort of like make the color code for this thing. So you just put this thing, and then you just go to conditional formatting, and then you just make a color, put a color. Okay, so you put color. So the color there shows that red is bad, green is good. So red is a lower score, the green is a good score. So you can see they scatter here and there. You have student number 1 is 78, so that is good. Student number 2 is near the fail, and so on. So you can see the data scattered. So this is real data. When you deal with the real data in the experiment and so on, you get this type of data. So it's difficult for you to make sense if you don't order this data. You don't arrange this data. So in order for example to arrange this data, you need to sort lah. Okay, so let me copy this thing. And then I copy this thing, and then let's say I put here. Okay, I just put here lah. Put here. Control V. The same. Okay, let me copy. I copy the entire thing lah. Copy, Control C. So this I want to show you how to work with data lah, the manual way. That's why we use software like Design Expert and so on. If not, you need to do manual like this lah. Using manual Excel, you can still do it, but yeah, it's tedious lah. So you have this data, but I want to sort it. So I want to sort this part. So in Excel, you can sort lah data. You can just go to sort. You sort. I want to sort the lowest to the highest. So I sort like this. Kenapa macam ni? So I want to sort from here to here. Okay, I want to sort the data. So here, the cell asks you whether you want to expand the selection or not. Expand the selection meaning that when you expand the selection meaning that if you sort this number at the left, the number 1, 2, 3 also will follow along. So let me sort with that. Sort. Okay. So you see student number 43 on the top, and then you can see now the data looks like this. If I make it smaller, okay, just to give you the overall view. So you can see they are like the hot here, the red, and then go to yellow, and then go to green. From this, just seeing at the glance, you can see that there are a lot of students in the middle. The score in the middle, more or less lah, in the middle. They have a dark red on the top, just a few, and dark green on the bottom. So somehow you can just see there are some normal distribution there. Okay, so you sort like this. Wait. Okay, so you sort the data in order to get the sense, to get the sense of this thing. When you sort the data, normally when you have a data, there are few things you can do. First thing, as usual, you find the mean lah. You can find the mean of the data. Okay, you can find the mean of data. So let's say in this case, Okay, in this case, what we call, I sort with the numbers. So let me, I want this because I want to put numbers. One, let me put this. Okay, here, and then I put one. Jap. I put yeah, here I put one, and then I put here this. Here plus 1. I just want to do like that. Okay, I just want to give the not the order, but just to make it like yeah, like to order lah. 1 2 3. So let me put like this. Okay, so and this, so I know that I have 63 thing. Okay, it's not like I sorting the thing, because the student sorting is this thing, but this is the what we call the actual data thing lah. So when you have the data, what you can do is that first you can find the means lah. So here you can find the means by just simply find average lah. So average, you can find average. So you click average, and then you just take from here and to them bottom. Where's the bottom here? No, I need to one more here. Okay, average. It's not average there. No, this is not correct. So this, let me put here lah. Average. Average. Okay, average from here to the top. Okay, and then enter. Okay, you get that average 64. So this average we call it mean lah. Mean, the one that we learned before, this is mean lah. This mean, control bold. Okay, you got mean there. So let's say so, and then so mean is one of way to sort of like tell the story about data. So you can say that so let me put this format cell into the what we call numbers. I put 1 is enough lah. Okay, so you know that the average, the student in the class score around 69.4. Okay, so apart from mean, you can also find other stuff like the median. Okay, the median is basically what we call the middle of the data lah, the middle of the data. So for example here, I have 1 until 63 student. Okay, in order to find the median, you need to sort. So for example here, I sort from 1. I sort this thing lah. Basically, I sort the mark from low to high. So I sort this thing. So I have 63 student. So the middle is basically on 30, 30, 31, 31, 31 lah, 30, 32 lah. Because you have 30, median is 32 lah. Median out of 30 is 32. So this is median. This is median. This is median. So you get this median. So median is 71. So I go like this. Mana? So like this. So this is median. Control Z. Control bold. Okay. So you get median there. And then what I want to do is that I want to also find the range. Okay. So now 34 is the highest, and the what we call the lowest is 92. So let me put range. So you have the highest one. So 90 minus the 34. Okay, so you get that thing. So that is range. Okay, so you now have 3 things that describe the data. Median, what we call range, and mean. You also can find mode. Okay, mode. Mode is basically how much what is the most frequent data in the ni lah, in the data set lah. So you can find, you just put mode. Okay, mode, and then here mode, and then you find from the data, and then you click here, and then you enter. So you get mode. Okay, so you get mode, control bold, and then you get this thing. So what does it mean by mode? Mode is basically what is the data that most frequently happen. So 65. So if you see here, you have many 65. 1, 2, 3, 4, 5, 6. You have 6 65. that is the most frequent numbers, actual numbers in the data set. So normally when you are in high school, this is the most common that you see lah. The median, the mean, the range, and the mode. Okay, so this is where all the statistics start. All the statistics start with these 4 things: mean, range, mode, and median. But the statistic that we interested start with mean. Okay, so now after we got that thing, then we try to scatter this thing. So we try to sort of like put this on the graph. We try to put this on the graph. So let's say you put this, and then you take this, and then you try to go insert, find the scatter plot. Scatter. Okay, you see something like this for this, because you already order. If I take the one that is not order, let's say I take this thing, this one, and then I take this thing. If I'm not order, if I take insert new graph, insert graph, you get something like this. So let me put here, so it's much easier to see, because now it's messy. So let me put, so that I put up, so it's easy to see. So let me wait for a minute. So let me put here. I just give you the idea lah. Okay, so here. So you can see 2 same data, but different scatter plot. Okay, so the first data is not, this not order lah. So let me put here, not ordered. Not data, not ordered. And this one is data ordered lah. Data ordered. Okay, so you can see the difference in scatter plot, how you will get. So when you order the data, you can see the trend. In this case, it's not really have nothing to do with the prediction lah. It's just to show you the trend only. There are somebody at the bottom, somebody at the middle, somebody at the top. But if your data is not scattered, you can also see the trend, because you can see most of the people in this what we call in this middle range here, and then some of them, you can see here. So some of them is below 50. Let's say 50 is the pass mark. So there are 1, 2, 3, 4, 5. 5% is like fail, and then few percent at the very top. But most of the percent in this middle. So when I talk about the what we call the normal distribution, you don't use this scatter plot. Normal distribution, you use the you plot based on frequency. Okay. So how to do it? You just simply, let's say I take this one, the first not order data, and then I take down, I go down, and then I sort of like find insert, and then I go to this scatter plot, this histogram. So you can see the histogram is like that. Okay, so let me put there. Let me put here. Let me put here lah. Let me put here. So let me put here. Let me put here. So you can see the scatter plot. So this is for not ordered data. Data not ordered. What is this? Data not ordered. Okay. If I do for here, from here, and I take the data until the end here, and then I make the what we call the scatter plot. Not scatter plot, the histogram. You get the same thing, exactly the same thing. Okay. Because it's not relate to the order. That's why people use histogram. They use normal distribution because it doesn't depend on the order. So this data ordered. So you can see this is what we call the graph that you get from the data. The first one we call it scatter plot, and the scatter plot depend on how you order the data. But we interested when we do this analysis, statistical analysis, more often than not, you deal with the distribution in terms of whether it's normal or not. So it's depend on the frequency lah. So when you have this the histogram style, then whether it's order or not order, it doesn't matter. That's why when we talk about what we call the normal distribution, that can be standard because it doesn't rely on the order or not order. So that's why people use this thing. Okay, so now let's say I take this thing. Okay, let's say I take this thing. Let's say I make a new. Let's say I make a new thing, and then I interested with this only. Let's say I interested with this part only, the order part only. Let's say I take all this thing. Let's say I just copy everything because this quite messy now. So like copy everything, and then I put at the new sheet. Okay, Control V. Okay, so this is data that we have ordered, and we just want to see how to calculate all the other stuff lah. So after you have all this thing, after you know how the data is distributed in the graph, then we want to learn about all the stuff that we do here lah. Okay, so mean we just average, so the variance is just the sum of the square over n lah. So let's say this is just one class, so we assume it as a population. So in order to find variance, then we just take the what we call the data of interest minus the mu, each data x is each data lah, minus the mean, and then we square it. You understand the reason why we square is just to avoid the cancellation, positive and negative. So we going to do that. So basically we put here, maybe we can put here x minus mu lah. Insert format, insert symbol, maybe they are mu, insert mu. Okay, so x minus mu. So basically what actually this is basically the what we call this thing, the value, the x value minus the what we call the value here, minus the value here, mean is mu lah, minus the average. So minus the average, you get that, you get what we call negative. So and then if you go down, so you get all this thing lah. So this is basically all the what we call, this is not right, this is minus mu, this no, this is, oh, because I go until down, I think just minus ni lah, minus 60, minus just put numbers lah, 69.4 69.4. So that's basically that thing, and then you try to do it down, and then you get all this thing. Okay, you can see when you do x minus mu here, so let me put in the middle there, and then I make bold, so you can see they are negative, they are positive here. Okay, positive, they are negative, positive, so that's why you need to square this thing. So let me copy this thing, Ctrl C, Ctrl V, and then I square this thing, I square this thing, I square this thing. So I put square, and then maybe I put this font, and then superscript, and so on. So basically this, I want to square all these things. So I just put that, and then I want to say square this thing, square 2. Yeah, okay. So basically what you do is that you square the each division lah. Okay. So after you square, apa sampai sini, Ctrl Z. So I want until here only. I want until here only. Okay. Okay. Yeah. Okay, I want until here only. Okay. So you get that. Okay. And then you find the summation. So let's say here, because if you look on this table here, after you square, you sum the thing. So you sum lah. You sum this thing. So basically here, you just this and put sum lah. Sum of the square. Sum of everything from the data that you square lah. So square, so you get this thing, you get 108 this thing lah. This not right lah, 23 92 like that. 108 109 is a little bit different lah. 37 34, this is 94 99.4, this is 99.4. So is I minus this 99.4. This is basically f6 x minus mu. So this x minus mu. Okay, this is 34. I not get the same like I do before. 99.4. Wait, so this is the mean, 99.4. And then when I minus the mu meaning that you take this thing minus 91.44, you get this thing, and this is 34.9. Why I don't get this thing? Wait, 99.4. So let me double check first. 99.4. Okay, that's correct. So I make mistake here. It's okay. So now we already sum the thing, and then this is basically the what we call the summation of the SS lah, sum of square lah. So we put here sum of square. Let me put here. This is sum of square. Control bold. Okay, so let me make it something like this, so easy to see. So this is two things that is important: the mean, the sum of square. Once you got the sum of square, you can calculate the variance lah, because you can calculate the variance. Okay, so the variance is basically you just do this thing and then divide by n lah. So variance is basically you take everything here, and then divide the number of the observation. In this case 63. So you divide by 63. So you get that thing 171.8703 lah. So that is the variance. So when you want to find the standard deviation. So let me put this text like that. So standard deviation is basically this thing. You what we call, because here if you see the variance, if you look here in this thing, the variance itself is in square. So you need to put back into S. Okay, this you need to put back into the ni lah, the you square root the thing. So you just basically square root lah. So this SQRT square root, and then you take this thing and then you get that thing. So that is basically what we call the deviation. So let me put this is the thing. Let me put it in the format cell, and then I put it number 2 is okay lah. 2 is okay. So you get this standard deviation, variance. So you get all these things, standard deviation and variance. So what all this mean? What all this mean? So if I want to draw this on the, let's say I put in this thing, what does it mean is this. I have something like this, and then I have the standard distribution, and then I have mu here, color line, and then I have the mu here in the middle. So the mu is basically what is the thing? Let me see. The mu is 99.4. Okay, and then what else? The variance is 17. The standard deviation 1311. What does it mean? Standard deviation here. Standard deviation is 13 point. Lupa lah. 13.11. So this is your standard my standard deviation, the standard deviation for the class. You have something like that. So what does it mean, this 13.11, meaning that one standard deviation is here. So meaning that if I put here this one standard deviation, this is two standard deviation, this is one standard deviation, this is two standard deviation. So here is basically 13.11, not 13.11, meaning that 69.4 plus ni lah. So if you have this, it's basically 69.4 plus 13.11. So you get what? 69.4 plus 13.11. So you got 82.51 in term of score lah, exam score. So here you do the same thing. Here the value is basically you tambah, you still add 13.11, so you get around 95/62. So you get the value lah. So here same like that, you just minus lah, 99.4 minus 13.11. So you get 99.4 minus 13.11. So you get 56.29 here. So here you get what? You get 56.29 minus 13.11. You get 43. 43.18. So you have all this thing. This thing, in yellow is 2 standard deviation away. In green here is the score 1 standard deviation away from the mean. Here the mean is in the middle lah. This is mean in the middle. Okay. So when we learned before that when you are 1 standard deviation, for example here, let me put the color apa biru. Let's say you have here, we learned before, if you are 1 standard deviation from the mean either side, then this area encompass 68%. Based on the based on table lah. So how to find this? Let's say you have this thing. How to make sure this 68% is basically, you can see here 82.5. So you need to convert into, in order to convert into the normal distribution, the standard normal distribution. Let's say this, and then we have something like this. Let's say this standard normal distribution. We know before that standard normal distribution, let me make it bigger lah, is here mu is 0, and here is 1, -1, this -2, this is 1, this is -2. Okay, this, the area here we don't know yet. Actually we don't know yet. The one that we know before, the one that we discussed before, where I think here, yeah, when we discussed before here, this 68% is basically based on standard normal distribution. This thing, 68% is based on standard normal distribution. So to say that if you have something like this, you don't know yet how much is the area, but you know from the standard deviation, this you confirm, this is 68%. So in order to convert this, this is your data, this is your distribution data, okay, so this is your distribution data. So your distribution data, even though it look like the normal distribution, because why I say it look like normal distribution, because if you see here, if you look here, the graph, the histogram that we got is more or less like normal curve, the bell curve. So that's why we say that what we call this thing is more or less what we call the distribution data lah. So but we have distribution data. This distribution data is not equal to normal distribution. So in order to convert this, you need to use a table lah. So in the table here, in the what we call this probability table, you can see something like this. They say what? They say in order to get the value, you need to convert like this, z x minus mu over this thing lah. So let me put there. In order to convert this, you need to use z equal the x minus mu over the standard deviation. The x is your score, and the mu is the mean, and this is standard deviation lah. Standard deviation. So if you put the value there, let's say I put the value, so the mu is what? The let's say we want to see the area between this and this. Let's say we want to interested between this and this. Okay, we know this point is 82.51. We know this point is 56. So okay, we take this first lah. 82.51 minus mu. Mu is 99. 69.4. So you divide by the standard deviation. Your standard deviation is 13. So standard deviation is 13.11. So when you do that, you get what? You get 82.51 minus 69.4. Dapat ni lah, satu lah. You get what? You get 1 lah. You get 1. Okay. So when you do that, you get 1. Because you get 1. Because we are going on 1 standard deviation, right? So you get 1. Similarly, if you do this thing, you get 1 lah. You get 1 also. If you do this thing, you do this thing, 56, let me put here, 56.29 minus 69.4 divide by 13.11. This also you get you negative 1 and negative 1. That's this one you get negative 1 and 1 here is basically what your score, what your actual score looks at normal, standard normal distribution. And we see before, if let's say this is 1, so meaning that if you go to this thing, if you go to 1, number 1 here, and then 1 0 is 34.13, 0.3413. So 3413. Basically this 0.3413. Because it's symmetrical, so this also the area with this is 34.13%. This also, the area is also, because it's symmetry, is also 34.13%. So you combine together, you get what? You get, let me remove this thing. You remove together, you will get the 68 lah, 68% like that, roughly 68% lah. So that shows what? That shows that from here to here, from between 50, there are 68% population between that have in my class that have the score between 56.29 to 82.50, from 56 what you call 56 percent to 82%, meaning that I can see from here, from 60 to 60, what you call 60, remember, sorry, 56, 50, 82. So from 56 here, from 56 here, 56, when 56, so around 56 here, around roughly 56 into what? Into 82, if I'm not mistaken lah, from here. So from here, from that highlighted part, okay, so that make, let me put here, so this make 64% of my ni lah, 68% of the total population. So that's basically how you use your ni to your data lah. Why I show this? Because you try at least once lah. Try to do this at least once, and then you get experience doing manually. Because of course you can do it. What we call, you can do using formula. For example here, one more thing, standard deviation. You can find standard deviation. Let's say I use formula, Excel formula. Let's say I use Excel formula. If you want to, this I want to show. I showed you this because if let's say you don't want to use software, you want to use the manual style. Let's say wrap test. If you use Excel formula, you get for this thing. Let's say I use, let's say here, I put here and then I want to find STD. So you see there, they are STDS, STDV, and so on. Okay. So this thing, you can just get straight away lah, standard deviation, and then you just take the standard deviation for your sample here until there. You get that thing, and then you get 13.2, more or less the same lah. Because remember, I'm not using, I use only 2 decimal here. That's why they are changed some difference here, because I don't include all the decimal. So basically, it's more, you get more or less the same lah about the standard deviation and so on. So that is just one part. I mean, that is just what we call just until here, until here. And remember, when you want to perform the statistical analysis for your data, when you do the experiment, you have a lot of data, you do statistical analysis. Basically what they do is this thing, and they will convert the p-value and so on. But remember, we just until here only. There are a lot more there and there, p-value, f-value, and so on. So this is where the software come into place lah. If not, you need to do it manually, one by one. If you know the statistic, then it's okay lah. Even if you know, it takes time for you to do one by one. So that's the reason, as much as we don't want to rely on the software, but software save our time. So you view like that lah. Software, you have software like Design Expert, JMP, or Minitab, the software, the three main software that normally people use for do DOE. The purpose of that software is basically to ease your calculation. You get it straight away, rather than you need to put the data one by one. If not, you need to rely on this, and here only after one data set. If you have like many data set, then is other thing also, the different also. Okay, enough for that. Enough for this the discussion about how to get all these things. Okay, so I want to talk a little bit about the importance, not the importance, I mean that how you can use this to check normalcy. In DOE software, you often see, okay, in DOE, you often heard the term half normal plot and also normal plot. What is this plot? Okay, so later on you will see you can find this term. So this normal plot is basically the test for normalcy. Is basically this half normal plot, and normal plot is basically the test for normalcy lah. Because at the end of the day, your statistical analysis is based on the standard normal distribution. So this is the test to assume the normality. Assume the normality. Okay, so you have normal plot graph. What we did before, this one, the graph that we showed before, this is scatter plot. But ordered. This is like a distribution. But normal plot is a little bit different. Normal plot, they are different a little bit. This graph is handy because what? Because it because the normal, if let's say if your data is normal, then it will fall into straight line. Okay, straight line. Because if you have this data, the distribution, this is simple lah, but sometimes you get like not clear. They are like peak in the middle and so on. So this normal plot is basically make things easier lah. It will show you whether your data fall under the normal or not. Okay. So this thing, the normal plot, is basically how to do it is basically you are taking this data, especially you are taking mana data, this thing. Okay, so where is this thing? Okay, let me here. Okay, so you see at the top here, you can see you can this we want to find the region. Okay, the one that we did before, you want to find the region of interest. But if you want to find exactly one point, for example, let's say this, we want to find the between this and this, right? But let's say you want to find exactly one point here, this point, exactly this point, let's say 70. So the 70 you correlate with this what we call the standard distribution graph, you will get the probability. Let's say you want to find also here, you will get, let's say this is yeah, this 78, let's say this 70, you get some probability. You want to test here, you get some what we call some let's say this 57, so you get also some numbers, some probability there. So when you try to do for all the data, you can have each data have their own probability. So if let's say I put here, so I think I already put there, let's say this thing, let's say this thing, where is the thing, I don't remember. So this normal, so you can see here, so each data, let's say I convert into z-score. Remember the z-score, the one that in the table, in this table you have z equal to x, your data point. This is your average. This is your standard deviation. We see before how to calculate the standard deviation. So let's say you convert all the data that you have into z, and then once you get z, you can find the probability under the what we call under the curve. So if let's say you do all for each number, let's say this all each number, all your data point, you find the z-score. Okay, you find the z-score, and once you got the z-score, what you get, you can find the corresponding percentage through the table, via the table. Let's say I convert this into the percentage, you get something like this. Okay, you get percentage like this. Okay, so each score I correspond to the percentage on the normal distribution graph, meaning that there are 0.37% people got 34 marks. So that's what does it mean lah. So you see 65, there are 37% people got 65. So more or less like that lah. And then if let's say you try to plot this, if let's say I try to plot this to this, and then I try to plot cumulatively. This is cumulative, this is not this is cumulative. This is not this is cumulative, meaning that the z-score is this just cumulative 37. This not like it's not like this 71 54%, meaning that 54%, meaning that half of the class gets 71 lah. This is basically not that. This is just cumulative. From 0 you add, you add up from the bottom, you add up. Okay. So because if you look here, if you look at the normal distribution graph, if you see a normal distribution graph like this, like that, okay. Let's say you want to see this point. Let's say this is 50%, 50. The mark is 50. This is, let's say the middle is 69.4, and then there are another person got 51, another person got 52, another person got 53, like that. So if you find this, you can find this area. But if you try, if let's say this is the first person, you get this area. If you find this thing, if you want to find what is the amount of 51, those person got 51, so you can start here. But this area, they will cover the entire area here. So it's cumulative. If you find from the table this score 53, then it's basically they cover from here to here, from here to here, from whatever, from 0 to 53. So it's cumulative. So the z-score is like that lah. It depend on your table. So that's why in the table you can have something like this. Let me put like that. Okay, you can have something like this. The area here, some area like this, some area like this. They go from bottom. If you find one z number, so that's basically the area from the start until here. It's not from mu until here. They are also the distribution graph start from mu to z. So like this, you need to multiply 2 lah if you want to find both sides. So this thing, this value is a cumulative. Okay, it's cumulative. So if you try to plot this graph like this, and then you plot into graph like that, so you get something like this, straight line. Okay, if you see the graph like this, okay, this is what we call normal plot lah. Although the what we call this the actually this y-axis in normal graph, normal probability plot is a little bit different. If you want to draw this graph, the axis is a little bit different. It's like this. It's like 50 in the middle, 50% in the middle, 100% in the top. But then the what we call is just the scale is a little bit different. I mean that they sort of like it's like this. It's like this. Let me show here lah. Okay, the graph paper is like this. Okay, you can see this is in percent lah, 0% to 100%. In the middle is 40, is 50. But you can see the different 40 to 50 scale, and then so this small, but this from 1 to 10 this big. So this is what we call the probability graph. A little bit different than the normal graph. So the scale is different. So for this is 1 here. This is 1 to 10. But 10 to 20, that this small only. 20 to 30, this small. And then it is open up again. So in the middle is 50. So that's why this is not really true graph lah. But at least you get some idea. If you put this plot in the normal probability graph paper, then you get straight line lah. So now you see all the data in straight line. So when you see the data like this, we can say that what we call the data is normal. The data is normal, mean that you can use the normal distribution curve in order to reject the hypothesis or to accept the hypothesis. Okay, so this thing, normal plot and half normal plot, you will see again and again this normal plot and half normal plot. You see again and again in graph paper. You basically you can view this thing. It's like this lah. You can view something like this. Okay, you can view something like that lah. That's why this is, yeah, you can somehow like this, somehow like this lah. You can view somehow like that. But the real probability graph is like this. Okay, it's real is like this.